So it's a very interesting question. What could be accounting for the lull in cases that we're having right now based off of our wastewater data? And here I'm using California only wastewater scan data because at least for the past two winters, we rolled right from a summer wave straight into the winter wave. So we can see that in 2023 here and the same thing in 2022. But this year we had the summer wave and then it just flatlined. Where the last time this happened was during the winter of 2021. And the short answer is we don't really know, but there's a lot of factors that could go into play. So starting off similar to the summer wave of 2022, we had a very early and a very long summer wave, where it essentially started around April and ended around October. And when we have a long summer wave, we have a lot of infections. And when you get infected, you do have some induced immunity to the very specific variant that you were infected with. It's not going to give you a broadened immunity like if you were vaccinated, but you still get a little bit of something. Meaning that if there's not a lot of variant drift, you could have a little bit of immunity to contact with a future variant if it's similar enough. So next we have to look at our variant spread. So this dark purple is JN1, which was dominant at the end of winter last year, tapering off essentially through June and July. And we essentially have two different oscillating periods where we have a dominant variant like JN1 here, and then we have a period of diversification where the variants split off into many different facets. Where for a period of time we did have KP3.1.1, this teal right here, which really picked up, but it didn't truly dominate like JN1 did the prior winter. And now we're finally starting to have XEC, which is this dark green over here, which is now picking up and is likely to be the driving variant of this winter wave. And time will tell if it becomes a truly dominant variant like JN1 was last winter. Or if another variant comes out of the woodworks and is able to drive and become a dominant variant, because that's what happens. We have our diversification period, and then we have a dominant variant period. Meaning that it's possible, and we don't know this for sure yet, but it's possible that XEC isn't just that strong of a variant. And by strength, I mean the ability to infect a lot of other people very quickly. Essentially, this just boils down to luck. We've been in an excessively long period of variant diversification where we haven't had one just shine above the others. And then briefly going back to vaccinations, we had vaccinations available in September. So we had a long period of infections, which can give you a little bit of induced immunity to things that are very close to it. Not a broadened immunity. We had a period of vaccination right in here, which will give you a broadened immunity. And then we shifted from a dominant period in the summer to a diversification period in the present time, where a next dominant variant hasn't just risen from the ranks yet. And then the next factor that's sort of hidden is how we actually measure COVID in the wastewater. Because there's an N2 to N1 ratio and how it's measured, that's the nucleocapsid protein, two different types of it. And we assume this to be a 1-to-1 because it was 1-to-1 early on the pandemic, but ever since 2022, this has shifted. Where I'd recommend checking out this paper, I'm going to cover it in the future, but essentially mutations in the N1 region are resulting in an underestimation of the viral concentration, meaning that the measured value is much less than what the true value actually is. Where early on around July of 2022, where they first noted this, there was about a 15% reduction in the values. And later on, there was even a 40% reduction in what the measured values were. So they were 40% lower than what the true values are, which is part of why I really like wastewater scan and how they do it, because they only focus on the N2 protein and divide by the pepper-mild model virus for normalization. So their wastewater measurements aren't impacted by that change. But for other places like BioBot and the CDC, they haven't done any adjustments and corrections for this change that we know is happening. And as the virus continues to mutate, and if there are more mutations to that N1 binding protein region, then we're going to have lower and lower measured values over time, but the true value is actually going to be higher than what we're showing. So really there's a lot of factors at play. Some is potential measurement error that hasn't been back corrected for, and a lot of it really is just dumb luck.